Hello, this is Craig Bringer. I'm a student in CS3 or CSE 380. This is my Simicogo project. So this is my main. I create a board here. I'll show more of the code later. Then I create a state, passing that board as one of the parameters, and then some other parameters, which I'll explain later. Here's a while loop that runs while the terminal state is not reached. First, printing the board and taking input from the user. Then updating the state, checking whether that is the terminal state. Also, it checks each input to be a valid move or not. So then, once the state is updated, it checks if that's a terminal state or not, and alerts whether you won, lost, or tied. I've never had a tie. So here is the user's move, which when the state is updated, according to the move, it'll be the other turn, whether it's user or AI. And right here it calls the min-max to find its best move, and then updates the state according to what that best move is. So here I'll do an example of the game. I'll do play 5. 2, 3. He follows me for a while. I'm just gonna start going on top of him just to make it interesting. 4, 4, 4. Okay, yeah, AI is pretty good at making moves. It took me a while to be able to beat it, but now I beat it most times, except right now I'm losing horribly. But anyway, yeah, scores are updating. It all works. And so I'll go back to some code. Here's the column. So my board is an array of 9 columns. Each of them are initialized to be the empty string right here. Height is 0. Column full is false. I add pieces with this method right here. I add pieces from the board state class in the constructor. I'll explain that also as I get there, I guess. But basically here, when you add a piece, you add it if the column is not full. You add it to the index of height, which is 0 at first, and then you increment height, and then if the column's full, then columns full is true. And then here's some getter functions for those. Here's the board state. So the constructor takes in a board, true if it's the user's turn, false if it's the AI's, the column that was chosen to be added to in the previous state along with that piece, and then the scores. It updates all of the scores, checks whether it's the terminal state after it adds the piece, and then assigns the scores and assigns the utility function. So down here, setters and getters, there's the add piece function right there. Scores is what I wanted to show you. So I check first if it's column 0. That's basically for initializing the empty board because there is no column 0, it just returns. So if it's the first column, I check if the newest piece is the same as a piece below it, if the height is more than 1. Otherwise, I check the column directly to the right of it, in the index above, directly next to, and below. Then I do a check for if it's column 9, checking if it's the same piece as the piece in column 9 just below it. And then I check the column directly next to 9, which is 8, obviously. Checking the index above, directly next to, and below, and updating the scores accordingly. And then this updates the scores for all the other columns. So then down here, I calculate the AI utility to be used for the min-max search, which is just the AI score minus the user score. Return that, return the scores. So here's a board copy. Create a columns array. Copying each piece of the current board into that board and return it. Then I have a function here for generating the successors, which is a linked list of board states. I create board copies. I check if each column is full, and if it's not, then I create a successor state by adding a piece to that column. Then I return that successors array list, and this function here prints the board. So here's my min-max. I have one class variable. It's the AI column choice, which is updated after the search is done. So the search takes a board and apply chosen by the user. Then it checks the successors of the current board and updating the utility value to be the max. I basically look for the best utility value, assign a move according to what successor that is, and then the AI choice is updated. But so that calls min value, and that is right here, which checks the successors of that, which basically evaluates the leaves since it's done recursively. And the min value returns the minimum successor of the max. I'm sorry, it returns a minimum successor by recursively calling max value, which is right here, and this returns the max successor, which evaluates the leaves also. So all of those recursive calls end up assigning this variable right here, which is returned right here. You can use the getter function for it. So that's my code for this project. It was a lot of fun. Thank you.